Hello, I've had a question in Unit 4, Lesson 5. I'm looking at question number 12 here. Joe is driving west at 60 kilometers an hour. So I'm going to put Joe right here, and he's driving, oops, that would be east. Let's fix that up. So we got Joe heading west, and I'm going to say that this is in the x direction. So I'm going to say dx by dt, the change in rate of Joe, is equal to negative 60 kilometers an hour, just because he's heading west. Dave is driving south, 70 kilometers an hour, and they're approaching the same intersection. So here's my intersection. So Dave is heading in that direction. I'm going to call that the y direction. So dy by dt equals negative 70 kilometers an hour, because I'm going to say that south is in the negative direction, staying along with vectors. At what rate is the distance between the two cars decreasing? So that distance is, you can see it, it's a right angle triangle, so that's going to be a relationship that we're going to use. So they want to know, what is dH by dt? All right, so that relationship is x squared plus y squared equals our hypotenuse. If I take the derivative, 2x dx by dt plus 2y dy by dt equals 2h dh by dt. 2's are common, so we're going to drop those out. And I want to solve for dh by dt, which would mean it is x dx by dt plus y dy by dt. That's all being divided by h. So let's see what kind of information I have. I know dx and dy, so those two I know. When Joe's car is 0.4, so I know x and I know y, but I need to find h. So over here, we'll find h, and we'll just use Pythagorean theorem. So we would have 0.4 squared plus 0.3 squared equals h squared, or the value. We solve that, so 0.4 squared plus 0.3 squared square rooted is 0.5 kilometers. So we put that together. X value again was 0.4 times negative 60 plus 0.3 negative 70. That's all divided by my h value of 0.5. So calculating that out, so 0.4 times negative 60 plus 0.3 times negative 70. Divide that by 0.5, and we get negative 90 kilometers an hour. So that negative just means that it's a decreasing rate. So therefore, the distance between them is decreasing at 90 kilometers an hour. So if we go back and think of it in terms of your vectors course, the relative, from your perception, Dave and Joe, if they're looking at each other or can see each other's car, it looks like they're coming or approaching each other at 90 kilometers an hour. That's really what we just calculated there, relative motion. If you have any other questions with that, let me know, and I'll try to give you a hand and clarify.